-1. So let this be a screen. This already we have come across in waves and so on. Let me put once again here. So there are the 2-point coherent sources, S1 and S2, separated by distance d, small d. There's a screen where I'll put a condition, capital D will be very much less than small d. Now I want expression for order of interference on the screen. So they are point coherent sources. What are S1, S2? S1, S2 are coherent point sources. What is the methodology what we should work out here now? Try to think in terms of mathematics. They are like a not slit point source. Now you can ask questions, sir, who will produce such a coherent sources? Is it possible? Okay, we'll go to the optics. Let me cover that ideas here only, so it'll be easy for us. The application problems, if they ask you related to ray optics. So this is a lens. No, there's a lens. Upper part of lens is having 1 mu. The lower part is made up of some other material. So this will become mu1. This is a mu2. Let me, because coherent sources of light has to be produced here. So how to bring that coherent sources of light? So let a parallel beam of light incident on this lens. So now we know better information. What do you expect the rays which are incident on the lens above the axis will meet at one point? The rays below the axis will meet at one point. So from the so they'll meet at these points. So this will be the location of one focus. So I'll call this S1, S2. Now the primary question, are they coherent? What is the wavelength of light incident on the lens? Lambda. Then what is the wavelength of the light after refraction? Well, wavelength will change after refraction, no? Then, sir, maybe they have covered different path. Okay, let it be. But what is the coherent sources? Two sources of same frequency and the path difference and the phase difference between them remains constant. Yes, there'll be some phase, but that will remain constant with the time. So like this, what happened? I am able to produce now the coherent light sources with the help of the lens, where the above portion is made up of one material, below and the lower portion is made up of one material. Who will determine this distance d? This particular value. I think we know the formula 1 by f. So from where we'll bring it? 1 by f1. Let it be equiconvex length. So it's a equiconvex length. So the focal length will be r by 2 mu minus 1. This is f1. What is f2? R by 2 mu 2 minus 1. So what are f1, f2? This is f1. So what is the distance d now? f2 minus f1. So this should become equal to r by 2 . Got the idea? So they'll bring numericals of these kind of, you have to be careful now. After this, okay, let's come back here. Now I want the, first of all, how the pattern will be. Means like, what about the pattern? Now let's come for this one. It all depends on d, if d equal to lambda, if small d is equal to lambda, then what is the path difference of the rays arriving here will be lambda. If its path difference is lambda, what is the phase difference? Will be 2 pi. If the phase difference is 2 pi, I think directly for constrictive interference, what should be the path difference of the rays? Should be 0, lambda, 2 lambda, 3 lambda, 4 lambda, and 5 lambda. Like this, n lambda should be path difference. So therefore, if the distance between these 2 point sources, if it is equal to lambda, what do you expect here? Maxima or minima? Should be maxima. So who will determine it should be the lambda? Some adjustments here. I think it's not that easy really. Well, I'm teaching very happily. Within another 10 minutes, I'll wind up. You go to the lab, maybe you have to struggle for days to really get this point source. So you should focus all these things. Got the idea, no? So can I adjust this? By varying this one, by material or by varying radius of curvature. So many things are there for us. Okay, I can adjust the distance between the sources by looking at this setup. There's a background, have these things in mind. Okay, now if this is lambda, then what do you expect here? The maxima. If this is a 2 lambda, then also maxima. If this is a lambda by 2, what do you expect here? Minima. Got this? Okay, now the rays, suppose the rays arriving here will have a path difference, here I'll get maxima. So can I send a rays like this? Here the path difference is such that if it is equal to n lambda, then again we'll get one more maxima. So now, and it's mono screen. So go for a plane diagram. So how the pattern on the screen? The pattern on the screen will be alternate bright and dark bands will be there. This will be the pattern on the screen. So I want an expression for radius of nth order maxima on the screen. This is a now you have to ask primary question. Why the pattern will be circular like this? Why can't be rectangular fringes like what happened in YDSC? I think so. Just stick on to the basics here. Let me bring those two. Now look at this one. Now, if this point is maxima, then you are going to, on the screen, just go in a circular path of radius y. But I think I can't show more than this. So here in this particular, it's a screen. Screen means what? Will it be a line or will it be a plane, vertical plane? Screen will be a vertical plane. So on that vertical plane, go around in a circle of radius y. Then if this is maxima, then all the points on the circle should also be maxima. If this is minima, then all the points on that circular path should also be the minima. So therefore, how the pattern will be? The pattern will be alternate bright and dark rings. Alternate bright and dark rings. So I want expression for radius of the nth bright ring. And what is the order of interference? How that order will occur. So that has to be determined here. So that's what we are trying to do. I think you can go for analytical method, means like there's a ray 2, there's a ray 1. Who will cover more path? The ray 1 will, the ray, okay, this is the ray 2. The ray 2 will cover more path than ray 1. How much of more additional path? So this is the additional path covered by this. This is the additional path, what it will cover. Agree this? Now again, look at the conditions. What do you mean by this? Capital D very much small d. capital D very much greater than small d. What is small d? The distance between the two coherent sources. And the distance of the coherent sources from the screen is capital D. Now, what is use of this? I think again you draw the diagram in such a way, like what is the angle subtended by these two rays emitted by the source that reaches at point P with horizontal. What is the angle subtended by that? Will be theta. So both will subtend the same angle, theta and theta. So therefore, what is cos theta? Delta x should be equal to S2P minus S1P. This should be equal to, I will take the, look at the triangle, cos theta should be equal to delta x by S1, S2. So this will be the 90 degrees. From where I'm writing? From triangle S2MN. From the triangle S2M S1. Okay, no. This is. So now let's get into the, so delta S2P minus S1P is what the delta x. So what shall we write here? No, the delta x should be equal to d cos theta. S1, S2 is what? Is equal to d. So this delta x should be equal to d cos theta. No, cos theta, theta very small. Or so I'll go for expansion of this. This will be cos theta expansion. Let me write that one. 1 minus theta square by 2. 3 factorial. Anybody expansion of cos theta? Anybody expansion of cos theta? Two factorial, 4 factorial, no?
Yes, sir.
It should be like this, cos. Binomial expansion, let me recollect. Cos theta expansion. Cos theta, theta very small. Cos square theta, we can write it. Shall I proceed with this? One minus x square by 2 factorial plus like a 1 minus theta square by 2 theta 4 by factorial minus theta 6 by 6 factorial. I think yeah. Now theta very small, so higher order terms we can neglect. So this will be finally this thing. So let me write this delta x is equal to this will be much easier approach. What we have this one. So what is theta from okay, we'll go for small diagram. This is y, this is theta, this is capital D. The sources are in fact here. From the midpoint is what I'm going to indicate that theta. So theta very small, the theta will become tan theta. D1 minus 1 by 2 tan square theta. Tan theta, what we can write it as y by capital D. So the final equation, this will be D into 1 minus y square 2d square. So what we do will, what is y? Y the radius of the nth bright ring. Delta x will interested in the getting the position of the nth radius of the nth bright ring. So the path difference delta x should be equal to n lambda 1 minus y max square by 2d square. So this further simplification of this n lambda capital D y max is equal to 1 minus n by lambda small d capital D. If you want, we can take it outside. Okay, this is what what I should call this y max, radius of nth bright ring formed on screen. Okay, see once complete the description. So everything, the diagram, everything, who will produce, everything is available. Anybody having doubt, you clarify. So now some very good questions are there if you check the objective, and very good troublesome also. Let me use word troublesome. So there's a theoretical part. Now there are so many conditions are there. So like what we do is like at y equal to 0. What is y equal to 0? This particular axis is y equal to 0. Call this very specifically axis here. At axis, what is order of interference? What shall I do for that? At axis, what is order of interference? I should write y equal to 0. Definitely, what is this axis correspond for y equal to 0? To check what is order of interference. Anybody? What can be order? Shall we put 0th order? Like a central maxima, what we had in YDSC. And as I move, order of interference will increase. Please verify the equations you have. I want you to analyze here. Okay, there's a theoretically we derived equation. Now you have to analyze. Please do analyze the conditions. As y increases, order of interference will increase or decrease is what my primary question. You have to analyze this equation. We'll do one thing. Put y equal to 0. I'll get the order of interference d by lambda.
Yes, sir.
Okay, got this. So d by lambda. Now, as I move away, the order of interference will decrease, not increases. In YDSC, what happens? As you move away from axis, order of interference will increase. Central maxima used to be at axis here. So, sir, can you call this a central maxima? No, don't use word because we don't have fringes here. We have alternate, circular, alternate, bright and dark rings are formed. Don't say even bands also. Circular bands, I think we should not use. Alternate bright and dark rings. So can we find out the thickness of bright and dark ring? Thickness is put n equal to 1, n equal to like that for n and n plus 1. We can find out the width of that ring using this mathematics here. So now the order of interference in fact will decrease here. So what is order of interference? That depends upon d by lambda. Suppose say d equal to say like a 10 millimeter and the lambda is equal to 1 millimeter. Then how much order of interference will become 10? then next 9, 8, and where it will be 0, 0 will be at infinity, no? Path difference between these two rays will be equal to 0 at infinity. So it will start from here, no? 10, 9, 8, 7, 6, 5, 4, 3, like the order of infinity. So let's discuss slightly that particular formula, because the numericals are based on this end formula now. Nobody will ask you this derive, but the end formula, what the interpretation of that matters a lot. Now look at this. This, okay, the diagram. There's a D and their monochromatic source. There's a capital D. Now let me assume the values. D is equal to 10 millimeter for our convenient purpose. Or if you want to write phi, what is the order of interference that will start at axis now? I'll get here the phi. Next, what we get? 4, 3, 3, 2, 1, and again 0. Where this distance will be 0, 0, 1 will be at infinity. So what is that infinite distance far away? So where the path difference of these two rays will be 0 at infinity only. If it, unless the order of interference will start like this. Don't write again 4, 3, 2, 1. It's a circular bands. Circular rings are formed now, so it's not practice of showing here also that one. Just show it here. So what is this? The fifth ring will be formed, a bright spot here. Then the dark ring. Then the this, what is y4? Y4 is the radius of the fourth bright ring. We'll get the pattern of this one. So we'll determine. So what is the order of interference will decrease as you move away from axis. Go this one. So here if I write phi lambda, tell me like a omni, like a what would be the omni maximus you can notice. I should not say maxima, but okay, let me still ask like that. If I write phi omni maximus, you are going to notice. Means if you move in the vertical plane away from the axis like this, in this vertical plane away from the axis. So first what happened? Maxima, then maxima, then maxima, then maxima, then maxima, then maxima. So you counted 1, 2, 3, 4, 5. Below also same thing, 4, 3, 2, 1, 0. Then plus 5. So 11 maximas. If this distance equal to 5 lambda. If it is 3 lambda, instead of this d equal to 5 millimeter, let me write d equal to 5 lambda. So that will be more. Further, what will be that lambda value? Omni maxima. So total omni maximus on the omni times you are going to see the maximus, means here the axis maxima, then so altogether what happened? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 11 thing. Sir, why you are making 5 lambda? Can you make it this like a 3.5 lambda? It can happen, no? We can. These are the things which are there in numericals. So you have to be very, very, very careful. The application part. Now a student, what happened? You will make 7 lambda by 2. So what is that one? So what do you expect here now? At the axis, what will be noticed? I want you to, all of you to think now. Here maxima or minima. I think maxima, let me write it here. Maxima. Again, that numbers are okay. 1, 2, 3, 4 you are writing. No, minima or maxima? Anybody wants to answer? For destructive interference, what should be the path difference between the rays? 2n minus 1 lambda by 2. That 2n 1 minus lambda by 2, will it satisfy 7 lambda by 2? Yes. Lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, no, for destructive interference, the path difference of the rays. So what is the path difference here? Here we'll get minima. So what do you get here now? Now, instead of the bright band, instead of bright spot, so how the pattern will start with what? Dark spot. First dark spot, then bright rings will, then bright, dark, alternate bright and dark rings will come. So I think definitely the pattern in both the cases, some difference will be there. Rings only will be formed. Let me paste that pattern. These are very important. A student has to analyze here. There's no other way. Now, what can be the pattern in this case? So at the center, dark spot is what will be noticed. So this chapter, again, it's a unlimited. It will keep on stretch as we keep on introduce the conditions. Let me draw the pattern. Okay, this is the screen. On the screen, we'll have. So what is the path difference of the waves here? 7 lambda by 2. Next, after this, what will be the path difference? 3.5 lambda. Next, we'll get 3 lambda. Next, 5 lambda by 2. 2 lambda. 3 lambda by 2. Then lambda by 2, and the path difference between the rays arriving will be 0. Is it okay? Because far away, the path difference must be 0. Okay, now count it. So what are this? This is a maximum, this is a minima, maxima, minima, alternate. Here also the same thing. Minima, I didn't show it. So here you can put it like this. This is a minima. Dark band, minima means here dark band. So this is the minima. This is the maximum. What about how you count how many maximas? 1, 2, 3, 4. How many minimas? 1, 2, 3, 4. Below also that will be. So 7 minimas is what we are going to notice. But the pattern is something very important. I think when you get into problem, this has to be taken care of, the distance between the sources. Is it equal to n lambda or 2n minus 1 lambda? That will determine what should be the, from where, how it will start. But all the cases, the order of interference will decrease here. Here also you see that what is the order of interference is in fact decreasing. Any doubt you can clarify? I'll go for the next condition. You reach a 10th page. I'll post everything in Telegram channel because this recording now, like earlier link, not possible because I'm doing recording locally. In cloud, it's not possible. So in the Telegram channel, what happened? This particular video will be posted there. You can download also if you want. Okay, last one more. Till what time I can take class?
11 o'clock.
11, sir.
Anybody is having after 11 class?
Yes,
11 o'clock.
max.
11 we have maths, sir.
11 maths. Oh, started.